Welcome to the November 29th, the day after Thanksgiving, meeting of the Coast Division, our virtual meetup. We have 4 items today. I want to talk a little bit about the auction that's coming up, a little bit about modeling on the coast. We did end up not doing one here. That was my fault. I'm going to go ahead and schedule one for January 10th. I think that's a good time after the holidays. We should have lots of good modeling for people to send in pictures of, so we should have a good modeling on the coast. I'm going to do a little presentation on rewiring the ACCRS O Scale layout. We rewired that over the last couple of years and talk a little bit about how we did that and why we did it and why it was important. And then we'll just drop into to coast modeling for all our coast modeling and talk about what we're doing there. Just anyone.
Can I ask a question?
Sure.
Is everybody else having a
No,
problem hearing Phil?
Yeah, Phil's kind of wobbling, garbled.
Oh, great. So it's not me.
Okay. Hang on just a second. Let me see something here. I see.
Now we can't hear you at all, Phil.
But you look great.
Yeah.
I love the jacket.
Mm-hmm. Hey, Jesse.
Yes, sir.
Your name is showing up as Phil.
Oh, I think I'll hurt myself.
Yeah. We have 2 Phils on.
Oh, good. Okay, let me become me again.
Yeah.
Nope, that's not me.
Mm-hmm.
You're you on my screen.
I see me on the other one. Yeah, I see what you're seeing.
Mm-hmm.
Edit profile picture.
No, usually just go right on, put your cursor on your name and right click, and then there should be a rename on the menu.
Uh-huh.
Let me see if that worked better. Did that work?
Yeah, that worked.
Yeah, I'm sorry, I had to reconnect my video, my camera, which has the mic in it. I apologize for that. So I'm going to go ahead and just start over since everybody will be probably fairly comfortable with that. Apologize for that. This is the beauty of technology. Hang on. Let me get the right thing up on the screen there. There we go. Okay. Yeah, I've had this headset. I think I've got to replace it. It's no longer a good headset. It hasn't worked that well. Okay, can everybody see that?
Yep.
Cool. So welcome to the November 29th, 2025, the day after Good Friday, our Coast virtual event. Happy post-belated Thanksgiving to all. We have 4 things we're going to cover today. First is the auction that's upcoming. Second is we're going to schedule a modeling on the coast for January 10th. We did this once before. It's an opportunity to just send a few pictures of what you're modeling. We'll put it into a slide deck. It worked out really well before. We had a absolutely great presentation by Dave Adams about a car he built that actually I think won at the National Narrow Gauge Convention. Then I'm going to do a quick little clinic about what we did to rewire the ACCRS O Scale layout in Pleasanton, kind of how we did it, why we did it, some learnings from that. And then we'll go to our just coast modeling, anyone who's got anything to talk through. So first off, the auction. We are going to have the auction on the 7th of December. That's Pearl Harbor Day, obviously. It's going to be at the Mastic Senior Center where we've had it the last few times. Setup will be at 9, check-in at 10. Noon, we'll have lunch and a business meeting fairly quickly. Probably again have Costco pizza and water. So it'll bring, if you want soda or something, bring your own. We'll shoot to start the auction about 12:15. If you haven't seen the emails, if you send a note to Craig Mazzoa, at sandman2297@yahoo.com. Craig will send you auction cards that you can fill out. He used pre-printed kind of heavy cards because they hold together well. So those will come out from Craig. There are going to be some great items. Kevin Shanahan in San Francisco made a donation. He changed scales and donated a lot of HO equipment. So we've got some great HO equipment, a lot of cars, a number of Santa Fe and UP engines, a whole bunch of detailed models in HO, HON3. We also have some other models. There's actually a post on the PCRgroups.io. If you're bringing some items, take a picture so people will know what's going to be there. But there'll be a number of really great items, I think, this time. And one of the things we found, Kevin, in his donation, donated a bunch of detail parts. Couldn't figure out how to put these together in the auction that made any sense. So what we're going to do is we're actually going to set up at the registration table to have these out. And they'll be 50 cents each, or, some sort of a bulk if you want to buy more of them. But if you're looking for detail parts for your HO locomotives or HO cars, it'll be a great opportunity to get them. So we'll look forward to everyone taking advantage of that if you need those parts. The last point is we had to decide to redo the seller bidder database in the software. It was old. It had gotten very confused. So we've started again. You must get a new bidder's card. If you use this QR code, you can go get a new bidder's card. If you look in the Coast Extras, the recent ones, you'll also see a place where you can click and see all the bidder card numbers that have been assigned and find your bidder card number if you're actually getting cards before the auction to fill out. So if you're going to go to the auction, do this QR code or use that tiny URL, Coast Auction, to get yourself a new bidder number. I think we have about 58 bidder numbers assigned so far, so doing reasonably well. Obviously, you'll be able to do it at the event as well. Any questions about the auction? Guess it's very cut and dry. So we're going to schedule for December 10th, which is the first Wednesday we meet after the holidays. We'll do a modeling on the coast. So just send a few of your photos to that CoastSup23 Gmail account. That's the Coast Superintendent account. And we'll put your photos in a slideshow. And those of you who saw this when we did it with Dave Adams, you saw what Dave did. Just sent a few photos in and it worked really well. So go ahead and mark that on your calendar. Pick a few photos of a recent model you built and send them in. So with that, I'm going to go ahead and stop sharing. And we're going to move into the next part of this, which is hang on, I got to get rid of that. I got to go over here and do this. I'm going to do a little clinic about, well, that would be good if I hadn't killed the clinic. Hang on. Well, that sound thing kind of goofed me up there. Okay, here we go. So what I wanted to do is just do a little talk about how we rewired the club in Pleasanton, because I think it's an interesting discussion about DCC and kind of what it takes to get things to work today. So this is just kind of an overview of what we've done over the past 3 years as we've rewired it. And then I've also got a link to, we created about a 30-page description, operational description, and troubleshooting guide. And it's available as a PDF, and I've got a link for that in here as well. So if you want to, you can get this presentation either with the QR code or this tiny URL, ACCRS wire. Either of those will get you this presentation and then the link to the PDF document. So you guys, probably most everyone here is familiar with the ACCRS Club. It's at the fairgrounds in Pleasanton. Open during the fair, some good guys, train shows, mainly events that are on the fairgrounds. Really kind of restructured it to be very much great for the public to come in and see. The O Scale layout is a fairly large layout on one side. It has also an HO layout. If you look at the structure of the building, There are entrances on on two ends into the building. On the right is kind of generally considered the front entrance. On the left is the back entrance. On one side, there's an HO layout, and on the other side is an O scale layout. The O scale layout is basically a folded figure 8 with a crossover in the middle and a passenger yard and a freight yard. Overall, the layout's about 100 by 16 feet, 100 feet long by about 16 feet wide. So it's a fairly long and deep layout. And you can see where the dispatch panel is in the middle, which is where the original DCC control system was built into place as, you know, a 2-cab, A/B cab DCC system. There are duct-through entrances to go into it. We have a lift bridge going into the back. The way it was originally built was by the way, very large curves, 90-inch minimum radius. It was built with 9 DC blocks on each main line, 2 return loops, and 2 yards. And so I actually have a couple of pictures here of the layout, kind of where they are, and different kind of pictures of how the layout looks. And I'm going to skip that because I think probably most everybody on this call has seen the layout at some point. But I thought I put those in there to kind of get an idea of how the layout is and how kind of long and skinny it is. So about 2005, somewhere in that time frame, they added NCE boosters to each cab with a simple double pull, double throw switch, separate switch for each cab. So that was kind of the first step, and you kind of see the control panel here. You can actually see there was a button that was a switch that was added over here to switch, but there are 2 switches to switch between DC and DCC. It turned out that created a fairly major decoder issue, because if you happen to be running your engine in DCC and someone threw a turnout and you switched into a DC block, it turns out DCC decoders don't really like being hit immediately with DC, and it tends to actually create lots of issues. And that, in fact, will damage most decoders. So one of the things we did about 4 years ago, maybe 5 or 6 years ago, was changed to a single switch. So we kind of began a transition from DCC being an oddity to DCC being the normal mechanism. And as we used DCC more, though, another issue emerged. And that was that if you looked at the layout from the booster, which was wired right next to the central DC panel, the wire out to the farthest block, which was out there on the far left, actually was almost 100 feet of wire. And it turns out that DCC doesn't really like long wire runs. And it turns out in O scale, that's actually magnified by the demands of current for the locomotives, because they have fairly high current demands. They can have 2 or 3 amp even outputs. We first started noticing this with some of our locomotives. For example, had an Atlas locomotive that had an Atlas factory decoder in it. Because we run for events that are, you know, from noon in the morning to 11 o'clock at night kind of things that often are 10-hour running shifts, locomotives typically run for 2 or 3 hours at a time. What we found was that with this Atlas locomotive, it would all of a sudden, and it typically happened back in this corner, all of a sudden the whistle would go off or the horn would go off, and it would not be able to be turned off. You could not turn it off from the DCC cab. The only way to resolve that issue, we found, was to take the locomotive upstairs, reset it back to factory settings, reload it from JMRI, and then it would be fine. Having been in electronics for a long time, typically that kind of thing is caused by a write bit error. So something was being written to memory, it was not written properly, it was written to the wrong place, and it turned the horn on and the horn wouldn't go off. That's typically a factor that you've seen in data errors in transmission, and typically was happening after the locomotives were warm. This was exacerbated pretty dramatically about 2 years ago. Sunset, who makes a lot of the O scale locomotives, went to lock sound decoders. And we had a couple of our members that one who had bought a new Sunset locomotive, one that had a couple of Sunset locomotives converted actually by the guy who did the DCC decision work for Sunset. And he put in lock sound decoders. And what we found was all of a sudden these locomotives would be running on the layout and they would become zombies. And because by zombies, I mean they would literally run and there was no way to control them. You couldn't slow them down. You couldn't speed them up. You couldn't stop them. And it typically seemed to start happening back in this same place. So when David Gibbons was here, he actually brought his scope out and we started looking at the wiring and what we were seeing in DCC signals. So these are some pictures of the DCC signal on the wire that we were seeing with those lock sound decoders in that both in short blocks and the far blocks. So on the top, you see the DCC signal with no load. On the right, you see the lock sound decoder on a short DCC bus. Hang on. Sorry, I had to mute someone there. So if you look at the right, you see there's a lot of noise on the wire all of a sudden on that short DCC bus. And if you actually look at the timing between those spikes, that's actually the 40 kilohertz cycle of the PWM, the pulse width modulation circuitry for the motor. So, the way DCC decoders work is they're not like a DCC power or DC power supply where you change the voltage from 0 to 12. The way they work is they have 12 volts and they slice it back to 0 and then go back to 12 volts occasionally. In this case, it's about 40,000 times a second. So they turn on the power just for a short little bit. If the engine's going slow, they turn it on for longer if it's going fast, and then turn it on completely for the highest speed. The problem is what you see down at the bottom right, or bottom left, which is in that far block 9 with that 100-foot DCC bus, that noise that was being thrown out by the decoder is magnified dramatically by the inductance that's in the wire. And we ended up getting so much noise on that circuit that literally the decoder would lose what's called the I pattern to be able to read the data that was being transmitted on the DCC wire. And what the problem with it is once it lost that signal, even when it was moving and the PWM circuit was going and it got to what's on the upper right, it could no longer detect the actual data signal. So it literally would never detect another data signal. So what we realized very quickly was that this was a major problem. We really had to change things and we had to get the system out closer, the power stations out closer to the blocks in the network. So we had some DCC goals as we set into this. We wanted to reduce DCC wiring to 30 feet from the booster with an absolute 40-foot maximum. We did not want any snubbers. We wanted to provide detector motherboard slots for up to 120 detector blocks per a 1961 SB-CTC plan one of our members put together. You actually see that on the next slide. We wanted to enable the 2 main lines and the associated sidings to be run in DC. So one of the things that happened was more and more members had DCC locomotives and members that had only DCC locomotives departed the club. What we realized was that DCC operation was becoming kind of the norm. But we still felt that having a DC operation as a fallback for shows, like for example, for the fair and other shows, as well as an opportunity for members to run locomotives before they did a DCC conversion to make sure they mechanically were sound was a good idea. So basically we said, let's do just the main lines in DC. So all the sidings and yards would be DCC only. The main lines would be DC. And then all those other sidings and reverse loops should be unpowered when you put the layout in DC mode, because DC is literally just running trains around the Christmas tree. And the entire layout must be switched from DCC to DC together. We wanted to increase the overall capacity of the main lines. We only had 2 boosters that had caused some issues. So we wanted to go to additional boosters for longer trains and diesel lash ups. The other thing we wanted to have a single power on switch. We'd had that previously with an AC power on that powered on the equipment by the dispatch panel. So you had one AC switch, you could turn it on, turn on the layout power, turn it off, and everything would go off. The problem we knew was that as we distributed the power systems, we sort of boosters out around the layout, they needed to be powered. If you powered them with a central 110, you'd have to run conduits out to those locations. So we decided what we wanted to do was use a 12-volt trigger signal that would actually be able to trigger all those stations to turn on and off without actually having 120-volt control. And then one of the other things was that having crawled under the layout, dealt with all those issues, said we should try to move all of our panels and all of this functionality to the edge of the aisle so it's easy to see, easy to work on. So that led us to a decision to plan for CTC. So this was actually, we started planning for CTC. We plan on using CMRI, and the club has acquired Chubb components and the New Jersey signals. We actually made a final buy from New Jersey signals just before they sold the company to Atlas, and we bought a lot of their O Scale inventory. And I think the deal he had with Atlas didn't account for the value of the inventory. So him selling that to us was all just cash in his pocket. So we actually got a great deal. So we actually have all the signals and all the CTC components we need to implement the plan that's shown here, which is actually a 1961 Southern Pacific CTC plan. One of the things that showed up was that increased from 28 to 128 or to 28 to 120 blocks. So our original DC layout had 28 blocks. When you go to this kind of a CTC plan, because of all the places you need detectors, for example, 2 turnouts and 2 tracks that previously in DC, or a main line, 2 turnouts in the siding that may have in the original plan been a single block, in a CTC plan becomes 4 blocks. So you go from 1 to 4. So basically what we said is, let's go ahead and put this together. We put in what kind of where some nodes could be for the CTC signaling. And that led us to a decision to put the boosters and the CTC equipment in really 3 locations. So the first location, and you kind of see these on the little plan up here, the main location is right inside the main aisle on the front. That covers this area in the front of the layout here. We then had another panel that's under a mountain of scenery back over here that covers this end of the layout, and another set of panels back in the back here that covers the back around here. You can kind of see how that's broken up here, up above. So at each of those locations, we needed to have 2 things. We needed to have what we called a power station, which would have the boosters and circuit breakers and other equipment in it, and then detector panels for the blocks. So this kind of shows where those were located. The power stations, 3 power stations, 1, 2, 3. And then there was a detector panel for power station 1. Power station 2 has detector panels here for most of the layout, but then has another little detector panel here for this area back in here. And then finally, we had a power station on this end with detector panels that covers this end of the layout. So each power station has boosters, circuit breakers, and then you'll see a DC to DCC relay. So this is basically what a power station looks like from the 120 volt side and the DC trigger wiring. So what you see on the left here is from the front panel, we have a DC switchover 12 volt trigger and a power trigger. Basically, the power trigger pulls in a relay, and that relay turns on 120 volt power into this power module from the wall. We also have a power selector switch that is a center off double pole toggle that lets you turn the panel on locally, turn it off so it can't get power, or turn it into what we call normal, which connects it to the relay so it can be turned on from the central panel. By the way, the 120 volt is actually wired to a wall outlet. So we treating these panels, even though you see they're made out of wood, they're enclosed and they're treated like an appliance. So if you want to work on them, what you do is just unplug them from the wall and remove the 110 volt power, and then you can work on them without worrying about getting hit by 110 volts. Basically, that 110 volt power then goes to a terminal strip, which feeds 2 transformers, 1 for each booster. We also feed a 30 amp DC power supply. By the way, if you haven't seen these are on Amazon. They're about 25 bucks, 27 bucks, something like that. Really nice to give you clean DC power for your layout. And then we put a panel fan in to keep things cool. The other thing we did is we found these relay boards. These are, each one of these is a single pole double throw relay. So basically each one of these has, you know, 2 inputs and 1 output, and is a single pole. And those are ideal for switching blocks because the common side of the block can all be tied together. One side goes through these. So this relay allows us for each block to select either DC or DCC for that block. And that is actually controlled by, again, a trigger switch. And if you notice, all of these are tied together, so they all switch at the same time. So what it does is gives us a really easy way to switch everything from DCC to DC if we want to. By the way, stop me if there are any questions or comments as we go through this. Feel free. From a DC-DCC wiring perspective, basically we have 2 boosters at the bottom of each of the panels. Those boosters feed in a cross fashion to 4 and 2 of the panels 4, 1 only 3 PSX circuit breakers. Basically, these 2 circuit breakers, 1 and 2, feed in and become cab A and B, and in this case, this one also becomes cab B. So those are split between the boosters. So what happens is would be cab A and DC, which is one of the 2 main lines, is on one booster. The other one is on the other booster. That splits our load. So if you've got 2 trains in the same area, they're actually, if they're on 2 separate tracks, they're split between 2 boosters. The only time we have 2 trains or multiple trains on a booster is if they're on the same track, which is kind of the way the layout operates, fairly unlikely. Then those outputs of the circuit breakers feed into these the DC relay board. Those are also fed by the cabs. So basically, each one of these becomes a block output, and actually there are the 2. Actually, I'm sorry, there are the 2 sides of that. There's the positive and the negative, and those then feed into a toggle switch and an LED. And then there are outputs up here. These are those like Wago connectors. They're the clamp connectors, but these are nice because they have basically 2 poles on each connector. So you can have, you know, both sides of the wiring to the track off the connector. So essentially by flipping this switch, we can go to DC. If we have a circuit breaker pop, it only impacts part of the layout. The other half of the layout continues to operate in that area. To support this, what we did was we did a distributed wiring system to distribute that 12 volt signal and the other things you need to run the layout. So basically, if you look at this, at power station 1 is where we have our DC command station. There's a command bus that runs from it. And if you notice, that's this yellow. It runs yellow, runs over to power station 2, then runs over to power station 3.
Phil, it's Frank. Is all the wiring color coded?
Yes.
Great.
It's all color coded and it's all pretty well documented. So, and then we've got a bus. The thing about the bus and the trigger wires is they don't have to be serial sequential. So we actually, if you'll notice, we split those here. So, you know, the trigger wires and the DC booster common go here and then go to each of these other 2 panels. So the idea here is at the front panel, you've got an on-off switch. You can flip that switch, turn on this part of the layout, and turn on all the control for the layout. And then there's a second switch you can turn on to switch the layout to DC. that will turn the main lines to DC and switch the rest of the layout off. So it makes it easy when you're operating the layout. So this is an example of the other thing we did. This is a pretty typical example of how people build model railroad wiring systems, and it's what I referred to as for lack of a better word, is single plane wiring. So everything is wired in a single plane, and you see all the components and you see all the wire. The challenge with this is grooming it, making it look good, managing it is a challenge. Plus, all of the electrical stuff, if you've got AC power, et cetera, is now exposed. So one of the things as we were laying this out, I had a memory back to when I was in college. I actually built if everybody remembers Dynaco, I built a Dynaco PAT4 stereo preamp and a Stereo 80 preamp. Built them in my dorm room in college. So these were actually, you wired them with point-to-point wiring and stuff. But what impressed me about this, I thought back on it, was these were really nice looking units on the outside. But when you opened them up on the inside, you saw all the wiring. While the wiring could be nice, it didn't have to be perfect. You didn't have to worry about laying it out the same way you did in a flat plane wiring scheme. So what we decided to do is employ the same technique. So these are our power stations. What you see is this is power station 1. This is the one that has the control booster in it, and also has an industrial area. So what you see is this panel here has the boosters. These are the circuit breakers. These are those switches, the DCC relays. These are the on-off switches. These are the connections to the layout. And then this is, and I apologize for the wire hanging down there. This was while we were working on some stuff. This is actually the detector panel that sits next to that. One of the things you'll notice is that all of these panels on the back have a cover that says do not open 110 volt power inside, because we do have 110 volt power inside of these. And by the way, you can see the DC supply here on the side, and this is the DC distribution wiring. So the idea is if you want to do DC, instead of doing what people were doing was putting a wall wart in, which somebody has to remember to unplug, you now just connect to the DC power for lighting for a building, and automatically it turns off when you turn the layout off. This is the one that's under the mountain. This is the detector panel, which is actually across the aisle from this unit. And this is that back corner. And we decided to put because of both space limitations, we decided to put the detectors into the fascia here. Actually was hoping they would be more visible from the aisle so we could talk about it. But it turns out unless you're 6'6", they're not really visible. But again, this is then that power panel for that area. And you'll notice we only have to have 3 circuit breakers there. We just don't have enough track there to demand a 4 circuit breaker. So basically, this is what they look like getting built. You see, this is the 3rd panel. This is the panel number 1. All the components are mounted on the face, and all the wiring, you'll notice, goes through the face into the back. And I'll show you that in a moment. This is one of the detector panels being wired. This is a little bit about what's in the power station. So we talked about this before, but you'll see at the bottom you have the transformers for the boosters. You have the boosters at the bottom. You have the circuit, then that feeds to the circuit breakers. They feed to the DC, and up to the switches that control each of the tracks. Very nice, by the way, for troubleshooting. So if you've got a short, you can flip this switch off. If the short clears, you know the short is out in the track wiring, not in something problematic in the panel. And then we have here the master power switch. You'll see that it's normal off and on, so you can control the power there. And then these are the connections up to the layout up here. We've also got a cooling fan back here, and we've got space down here. This was taken, this is the main panel. It's got the space for the command station, another booster for our industrial area, and then we've got a GMRI Pi, a Raspberry Pi that's running GMRI that does our Wi-Fi and does some other functions for the layout. So this is what it looks like inside. So if you look in the back, what we've done is all the wires come into the back. And basically what they do is, we start at the bottom here, and you'll notice that these are the wires from the circuit breakers or from the boosters. And you notice they go through some of those clamp down connectors, and then those separate the signals to go in here to the circuit breakers. Then the output of the circuit breaker goes to the DC relay. That also gets the DC, which actually comes from up here. The output of the relay then goes up to this switch with the light, and then that goes up to the output. So the beauty of this is that all this wiring is hidden. You don't ever see it, and it can be relatively clean, and it's in a space that's very open, so it's easy to wire. So these are the other two power stations. I just leave these here if anybody's interested. It's basically the same set of components in that. By the way, the reason these drawings are here is these are all part of that PDF I talked about that basically describes in detail. And the idea is if at some point in the future the members have to go maintain this and I'm not around or other folks aren't around, wanted to have a way that was pretty easy to understand what was there and how it was wired. So we had a decision to make. We started with this plan of doing a 1961 CTC panel. In fact, I started, if you look right here in the middle where all these green blocks are, this track, I started cutting the blocks up to match that CTC plan. So this was originally 3 blocks and became, as you can see, about 9 blocks. And we had that problem show up with the issues with the DCC operation because of the wire distance. And we made a very rapid fire decision that cutting the rest of the layout up into the 120 blocks for the CTC was going to be a huge amount of effort, a huge amount of rewiring. So we made a decision to take an immediate step to rewire the whole layout into the power stations using the existing blocks. So these are the existing blocks we have around the layout, including those new blocks that were cut there. And what you see is how each one is wired. And you'll see in a moment that becomes important because those are all documented and how they tie into each detector, which is incredibly important when you get to troubleshooting. So from a wiring perspective, we had to make a choice on wiring and did some investigation. And one of the things they tell you in DCC is you want to twist your wires so the wires are close together. There's really 2 reasons for that. One is noise in the DCC system, but the other is actually almost more interesting. It turns out that the DCC waveforms actually are in the area of AM radio. And if you put a big DCC wiring system in and you have the wires a long distance apart, it ends up looking like a big dipole antenna. And you end up throwing a lot of noise out because of the dipole antenna. So they recommend, generally it's recommended best practice to twist your wires for DCC. It turns out there's a pre-twisted wire, which is called zip cable. You guys know this all from the wiring you get on a layup, but more importantly, it's used for stereo wiring because it turns out the same exact things apply in a stereo from a noise perspective, that you want the wires close together when you transmit the signal off to your speakers. So what we found is this Chinese 12-gauge speaker wire you see there on the right. It's actually a zip cable. You can see that it's a black and red wire. They're actually molded together. It's Chinese 12-gauge, which is equivalent to American 14-gauge. Never understood how you have different wire gauges on different continents, but that's essentially what it is. We bought this stuff that's in a company called Install Gear. I think last time I looked, that 250-foot spool was about $60. So it's actually very reasonable. It is copper-coated aluminum wire. So it does not have quite as much current capacity as copper, but because we limit all of these to 8.89 amps with the circuit breakers, we weren't concerned about the current carrying capacity at the distance we were talking about, which is about 30 feet maximum. The other thing we did was we used Wago lever connectors. These are actually available at Home Depot, at Lowe's. Basically, these are really cool. They handle from about a 12-gauge. They may even handle a 10-gauge, but I know they handle 12-gauge wires all the way down to 22, 24-gauge wire. And what you basically do is you open that little clamp, that little orange thing opens as a lever. You slide the wire in, you close the clamp, and it clamps down on it. This has two absolutely huge advantages for wiring versus soldering. The first is you're not soldering under the layout and dripping solder on yourself, which I find to be somewhat untenable. The second is if you have issues and shorts, it's easy to disconnect wires and to isolate the short. Quite frankly, the benefit, one of the nice things about wiring and soldering is you can have a bus wire and wrap wires around it. You really can't do that with this. But what we found is for what we were doing, which we were wiring the existing blocks that were in place. So the 10 feet on the layout where there was a bus, where there were feeders to it, we retained that piece of wire. And then we would cut that and tie in with this new wire back to the detector for that block. We also at the same time chose a 14 gauge zip cable for our 12-volt distribution wire that's blue and brown. So one of the things we wanted to start doing, we had a layout that someone had donated a whole bunch of black wire, 12 gauge wire 40 years ago, and they used that wire for almost everything. So there was no way of telling when you got into the layout what a wire was. You couldn't even, not only couldn't tell where it went, where it came from, you had no idea what kind of signal and really what it meant. So we now have this 12-volt distribution that's good for about 12 amps. And again, we use Wagos and screw terminals for the distribution of that. So generally now, if you want to do something, if you're going to, say, light a building, what you can do is look around under the layout, find that 12-volt wire, and just run to the 12-volt wire for your building lighting. So the detectors we put in enough detector blocks and in the right locations for that SP CTC plan. So this is just an example of what the detectors look like. So this is actually the front panel. What you see is in block A and block B on the main line, there are not a lot of blocks there. PS1 detectors that are on block A, there are only 4 blocks in this area that are covered. And there are only 3 blocks on the B side. These blocks here are all those blocks in that area that I cut in to actually make it match the CTC plan. And then these blocks over here, these detectors actually feed our yard. They feed the yard panel, the yard feed, and the runaround. And the nice thing about that, again, is if you have a short in the yard, it's easy to identify where it is. What we've done is to make this easy, we've put detector assignments together for each of these so that you can go in and very easy to go in and see which one each is. And you'll notice all the wiring is labeled. These are shrink wrap labels that you actually print and you shrink wrap onto the wire. So all the wires are labeled at both ends as to what they are, so it's easy to find them. So these are the other 2 detector panels. This is the one in the back under the mountain. There's a 4th detector block there that's separate that I didn't take a picture of here. And then these were actually built into the fascia. Thought that would again be nice. So one of the nice things we got done with all this is in the DCC troubleshooting process has become a lot easier. So for example, if you have a DCC issue, if something stops, you'll know the area it stopped in. You go look at the power panel, you can see it from the aisle. And what you'll see is what you see in step 1 here. You'll notice there are 3 circuit breakers. The one in the middle looks different here. That's because when this light comes on, there's a short circuit. Once you see that, you can now use the switch above to switch it on and off to see. So basically, this will be off, the light will be off. When you switch this off, the light will stay off, but the short circuit right below will clear. That tells you the problem is out in the layout. Then the next thing you can do is go to the detectors. Again, notice these are all labeled PS1, PS3. This is PS3. You can go actually remove detector cards until the short goes away. And now you know which block it is in specifically. So it becomes really easy to kind of do this remote troubleshooting. So one of the things we did was we wrote up a fairly lengthy manual of operations. Has a lot of the things that are on these slides. You can see in there the layout of each of the panels. You can download it either using the tiny URL or the QR code. So that's all, folks. And again, I'll put that up that if anybody's interested. And that's it. So is that interesting? Probably for a lot of people, it doesn't really matter that much. You want to put it back up, Frank? Did you get it? Probably not of a lot of interest, but for some of you like Frank who've gone totally dead rail, this whole DCC stuff is now an anachronism. But it was a good project. We've been in an operational mode for about a year, and we've literally every problem we've had has been I will call it, for lack of a better word, a human problem. So, for example, someone in the yard running a locomotive past the break in the yard between the turnouts, so they short out the turnout. And again, it's really easy to find that by going through and figuring out exactly which of the blocks is actually being shorted. So with that, I will conclude and throw it back to everyone else to do some coast modeling or commentary.
Good clinic, Phil. Thank you.
Thanks. Appreciate it. Well, it's been an interesting journey for the club to get, but it seems like we've reached pretty good stability where, unfortunately, I live about 5 minutes away from the fairgrounds, and so for a period of time, I was getting regular calls. If I didn't go in the morning, we had a show, I'd get a call at 8:30, 9 o'clock saying, "Hey, we've got a problem here. Can you come down and do something?" And quite frankly, that's really stopped. It's actually been very reliable now. So, and that's important when you have a public facing layout. The club in Pleasanton this year will probably have almost 60,000 visitors. And, that puts it probably in the top 5 model railroads in the United States. Definitely places like San Diego and Chicago, the Museum of Industry have more people visiting, but I saw a thing about Greeley, and I think Greeley said they had 20,000 visitors. So, and people don't come to visit a model railroad. They come to go to the fair. They come to go to the train show, and they happen to see a model railroad while they're there. So it's kind of important to have it work well.
Hey, Phil, I want a great presentation. I would love to look at more of those pictures in detail. And so I would love if you post it as you usually do.
Well, actually, both, but if you look the QR codes, both the presentation is available as a PDF, but the document is available as a PDF as well. It's a here, let's see if I can probably pull it up here. Take me a second.
Could you link it in the chat for us?
Yeah, I can. Absolutely.
Yeah, that help. I don't have my phone with me, so
hang on. Let me throw it. I'll throw it in the chat. That's the easy way to do it. So first, I'm going to put in the chat is the this is the presentation. And then this is and that's the document. Here, I will. So I'll throw this up here so you guys can see. This is basically what, one of the things, again, we tried to do, what wanted to do was to make it so that you could, actually troubleshoot it. So, if you look at it, this is basically what that document looks like. I mean, it's got a whole bunch about the basic design. Most of the pictures that were in this presentation came right out of the document. So it's basically the same information in a lot of ways. And so it's got all of those. And then it's got, a lot more detail on all of the, the detector assignments and how each one's laid out. And then the last part is the troubleshooting. So yeah, so that's a PDF up there. And by the way, that's something I would highly encourage everyone to do. We're rewiring our turnouts, and we're going to do the same thing. Write a manual for that. I think if you're a club and you don't have some manuals like that, ask the people that do a project or write a manual, because that knowledge becomes tribal. And it's amazing how many times you ask a question, and it's like, well, so and so did that, and we don't know exactly what he did. So. Enough said.
You won't even remember what you did, Phil. You got to write it all down.
That's true. That's true. You don't remember it all.
Great
Anyway,
job, Phil.
Thanks. Anybody got any modeling to talk about? Anybody model over the holidays?
I'll throw in.
Good.
I'm doing two things. I unstuck a Leadville design boxcar kit. It had some 3D printed parts for mounting the door slides that were so small I couldn't see what the hell they were. And when I clipped them off the sprue, they disappeared instantly into the ether. So I put this into a box and didn't work on it for about 6 months and decided that some 1-inch nut bolt washer castings would look almost the same, and I can handle those. And so I just bought some nut bolt washer castings, and I'm going to I'm basically unstuck, what is a phenomenal kit. Leadville Designs kit is extraordinary, and I'm going to do one of their passenger cars after I do this. It's an extraordinary model. The other thing that I'm working on is I decided that I'm also going to get into NN3. I was in NN3 when I was in 11th grade. And so if anybody is interested in NN3, even a little bit, just curious, this is a phenomenal book. I got it from, where was it? monroemodels.usa, but it is an extraordinary handbook that goes into, it's extraordinary. It has articles about how to convert 3 or 4 different Markland locomotives to NN3, track work standards. It was $25. It's $12 now on the website. It's an amazing thing if you're even remotely curious about that. And then I decided to get one of these little, this is a Rokuhan Shorty. So that's a little powered unit that I'm going to make into my first NN3 toy, I guess. This is $23. I couldn't say no. It costs about $200 to get into an NN3 locomotive, and so I got to budget for that a little bit and negotiate. But I don't have to negotiate for $23. So it'll cost another $10 to put a KD coupler conversion on it, and then I can get a 3D printed shell for another $12, and then it's paint. So for about $50, this is not going to be the best performing NN3 locomotive. The newer Markland locomotives have 5-pole motors with double reduction. And my understanding is they can actually, some of these Z-scale mechanisms can crawl, which surprised me. But this one won't. This will be a little jackrabbit, but it's going to cost me $50, and it's going to get me back into the small part of the hobby. So I'm going to do ON30 to do modeling with the Central California coast. I want to build a North Pacific Coast Railway passenger train and run a long passenger train on the big, glorious CCC modular layout, because there's no way I could run a 7-car passenger train on anything I would have at home in O scale. And then if I want to run, do a layout, I'm going to do my layout, I think, in NN3. So that's what I'm working on.
Excellent.
Yeah, cool.
Any other exciting modeling?
Actually, I was going to say something to Bob. I've got most of the Boone Morrison
national or narrow gauge and short line gazettes if you would like them. All you have to do is pick them up here on Walnut Creek.
I could use second copies. I have the paper copies and I have the DVD. So the narrow gauge and short line gazette, the Boone Morrison's work on North Pacific Coast is inspiring and a guidepost. I hope to be able to use N scale to get more of the feeling of the city. Like Occidental was actually in a valley. And when you look at Boone Morrison's implementation up at the California State Railway Museum, it looks like sort of a flat scene, even though it's absolutely gorgeous. And so I wanted to sort of model Occidental in the valley that was Occidental, and in N scale, I can easily do that where the module would be 12 to 14 feet long in O, and then it gets down to the point where I can have the whole thing in N. So that's. But I appreciate the offer. That's very kind.
I'm just clearing things out.
Cool. So I'll share one picture, a couple of pictures here. This is so this is my now kind of home layout. You can see it's very much modules. This module, and this module are ones that are portable and removable. The one back here is fixed. And this one back here is fixed. This was my backdrop I built there. I think I may have talked about that. So the idea was to create a space where you could, have the TV, watch a football game on Monday night. In fact, we had Monday night football in trains this week. And it's coming together. You can see my lighting on the ceiling. And
wow.
And this is my control. This is a cabinet that actually is on a couple of just not, they're just rollers, not the ones that are casters that roll and turn around, but just straight. And so it has this is the control panel for this area. This is my lighting panel for the 4 lighting circuits. And this is the DCC. I get 2 pictures each. This is the corner module. Actually, this is built as a cabinet, so it's got shelves. You can't see them behind the curtain there. And then I'm doing these are those light picks, and I'm doing these are for card sorting for operations for each of the locations. So anyway, I'm getting a little bit of progress going here.
Nice, inspiring.
So
gorgeous.
Yeah, it'll come together. Hopefully, gives me something to work on.
It looks pretty together, Phil.
No, there's a lot left. There's always a lot left to do. Well, Frank left. I was hoping he was going to start showing us some pictures of what he's doing in the mountains. We should have harassed him about that. Oh, well.
Mm-hmm.
And, of course, Rich is now moving to Colorado, so we're going to lose him, and he's going to be building a new layout in Colorado because Colorado has what are the 2 most important ingredients for good modeling? Basements and lousy winter weather. So Rich is moving there. He's moving to an ideal place for model railroading. I guess Minnesota is probably incrementally better, but
no, Colorado's better because it actually has the steam trains you can visit in the summer.
That's true. That's true. So where Rich is moving, he's 20 minutes away from. He's 20 minutes away from the museum in Greeley, 40 minutes away from the State Museum, and 45 minutes, an hour away from Cheyenne. So he's going to be in kind of an interesting location. He probably won't know where to drive to.
Yeah.
So are we going to see you guys at the auction? Anybody planning to go to the auction? It should be a whole bunch of good stuff. It looks like. I'm hopeful.
I'm going.
I know Jonathan's coming. He said he's coming.
I got a lot of bot trays for sale, a lot of bot equipment, decommissioned bot trays. I got to sell a lot of it, right?
There you go.
People want it, or they do want it. They do.
Yep. Labart trains those are very collectible. I mean, those are especially I know the ones that was Rapido did BART trains, and I think BART kind of sponsored the first one. They sold out completely, and they actually are doing them again. I understand it. Very
I can't
popular.
go 10 car BART train my layout. I can go only about 5 or 6. Probably 4 is enough. I can't go 10. That's too long, right?
That's true.
How about 5 or 6? Probably about 6 is enough. 4 is enough.
Nope.
I can't go 10. That's too long, right?
That's the advantage of narrow gauge, short trains.
Mhm.
So you need narrow gauge commuter trains. That's the new hobby opportunity.
Metro rail. I'm doing Metro. Heavy Metro.
Up Bear Creek.
Guys, I don't know if you remember way back when I was 12 years old, which is about 60 years ago. There was a BART model that was sold that actually had aluminum bodies on them, and it had a Athearn rubber band drive in it.
Yeah.
I'm converting by the gear drive. It takes time. I got one gear drive. I'm converting it. It takes time after work on my day off.
They still run on HO track, which is instead of the 5'6".
Yep.
I can go up to about under 5. That's 4 units enough. That's enough. That's enough, right? Not 10. That's too long.
Yeah, as a vendor, creating a unique gauge for your trains would probably not be a good idea. You just wouldn't have the components for that. So I think doing it in HO probably was a logical thing. So
you might find parts in India. After all, 5'6" is the Indian state railway gauge.
That's true.
I think Jonathan Big will work today. I gotta go to basketball game.
I thought BART was actually 5 foot. Is it 5'6" or 5? Does anybody know? For some reason I thought it was 5.
5 foot is the Russian gauge.
Yeah, I don't know, but I thought BART was 5. For some reason, I and then just one of those things that in my brain I had. And I have no way of knowing if I'm right. I thought it was 5 foot, not 5'6". But 5'6" would actually probably make more sense because my understanding was they were going for a broader gauge for a better ride. I don't know.
BART's 5 feet 6 inches.
Oh, okay, it is. Then I'm wrong.
Unless you're counting E-BART, because E-BART's standard gauge.
E-BART standard gauge. That's the diesel, not gasoline.
Yep.
Yeah, it would have been really interesting to have had a transcription of the discussions when they decided to do 5'6" gauge.
Yeah.
What you just have to think through.
We have apocryphal stories about that. Mine was that they wanted somebody to design a track gauge, where a BART car would not be swept off by 100-mile-an-hour wind. Now, of course, the sharpest curve which this 100-mile wind would have to penetrate was in a tunnel in Oakland.
One of the interesting things might influence that is, I don't know if you know, but BART in Hong Kong were built by the same people, Roar, and they are identical. At least, I think Hong Kong's been upgraded. But in the 90s, every single piece of equipment in Hong Kong looked exactly like something at Union in our system. So it could be that was the standard gauge for BART just bought the system and it was 5'6".
Washington, D.C. Metro was also used.
Yeah, very similar. Some differences, but Hong Kong was scary the same when it was built.
After BART, the federal government refused to fund any rail projects that were not standard gauge.
Yeah, because Washington Metro, I just checked, is standard gauge.
Yep. Well, it's I'm assuming for them, for the challenge with it is that everything that you need to run a railroad has to be custom. You think about it, spreaders, great, anything that you do in terms of track maintenance, all those tools that are really pretty expensive. And a lot of them, think about rail grinders, right? You ever seen those those trains that run that are all those grinders that grind the railhead?
Yeah.
I mean, they're all designed for a specific gauge. If you want to go from standard gauge to 5'6", they're not going to be built to be adaptable. It's going to literally mean re-engineering the frame of that piece of equipment. It's a huge, I mean, you think about it, it's a huge amount of additional cost once you make that decision. It sounds really good.
Go ahead.
The designers of BART were very intent on not building another railroad.
Let's build something with metal wheels on metal tracks, but let's not call it a railroad. Yeah. That's probably the best example. That's probably a reasonably good example, not maybe the best, but a reasonably good example of the dangers of groupthink. Larry, you're muted.
Remember, this was all designed in the early 60s, of 1960s.
Yeah, remember there was no such system ever built like BART.
Except that most of Southeast England is third rail electric. And they could have learned some stuff.
What was it? The contract was Parsons Brinkerhoff or something like that.
Yeah. The consultants made out like really well on BART.
Well, they always do. They're like lawyers. They're sharks.
That's true.
I like the Warriors too. I'm working today. I'm so glad I make money.
That's good.
I gotta go to work today. I'm doing a Thunder game. That's a big one. Thunder Pelicans. That's a good one. Good one, right?
Yeah.
I work at Mission Bay Arena. That's a nice place to work. Right in that neighborhood. I like that new former rail yard.
Okay.
Yeah, that whole area is just transformed down there. It's
they got good food.
Yeah, lots of good food, lots of places to go. I don't know.
Good place to walk, exercise.
Yeah, it's not like there was when the American Freedom Train rolled through there way back in 1976.
Yeah.
Freedom Train, I remember that equipment, special.
Well, it's interesting. We haven't been to the city for quite a while, and actually we're talking about going up this year. We'll see. Has anybody been up to San Francisco recently? Well, obviously, Jonathan, you're close to it, but
I feel I'm close to it.
I had dinner last Sunday at Firefly in Eureka Valley.
Cool.
Well, having grown up in the city, the last time I visited San Francisco, I looked around and go, this is the city I grew up in.
Yeah. I was, we used to go every year on Christmas Eve. We'd go with, family, my mom, parents, when they were both alive. We'd go up to Union Square with the kids and look around. We just haven't done it. Kids are obviously a lot older, don't have grandkids. So, and I just was curious how much it's changed over the years to go do that. And, around Christmas. So definitely thinking about going up there this year.
Well, if you want to go see the puppies in the Macy's window, you better do it soon. They're there now, and who knows how long they'll be before Macy's pulls out.
Yeah.
My kids are off touring Christmas markets in Czechoslovakia and Poland this year.
Wow. Well, the problem in San Francisco for retail is really threefold. I mean, there's the general problem with retail that, online has brought. And that we all know that from the hobby shop, right? I mean, when was the last time you went to the hobby shop to buy something?
Last week.
Last week. And it's there is this interesting thing that says that if you don't support local businesses, they won't be there when you need them. But then there's that's kind of the whole first thing, that there's this huge challenge in that side. Then from a San Francisco perspective, they've lost so much downtown business because of work from home, et cetera. And then of course I think they've had retail theft problems as well. I don't know how significant that is. I don't know. I can never tell from the press how overblown it is, but it seems to be a challenging environment. I know that.
I just want to throw out that I went to Berkeley Ace Hardware. The only problem, I've been going to Berkeley Ace Hardware since I was a little kid. When it was on University, they had Traxel. It was 2 stories. They had a huge downtown underground basement train area, and they ran a layout around the top. They moved to Milvia. The city of Berkeley screwed up the city streets. It's a one-way street, but it's still actually a decent hobby shop. With people who know it's HONN, but since I'm doing NN3, I can get structures and other stuff. I can't get NN3 stuff there, but I can get structures and supplies and stuff like that. So I just want to throw out a shout, because Berkeley Hardware actually, unlike Just Trains, where the last time I went there, I was saddened. When I went into Ace Berkeley Hardware, if you can get a park, it's absolutely a worthwhile place to be. And Berkeley is somewhat central to the Bay Area, maybe a little north for many.
Yeah. I go to Concord on Thursdays for my Toastmasters meeting. And one time I went over to Just Trains on a Thursday and they were closed. It says open on Thursdays by appointment only. So I'm going, oh, that tears that out idea.
Yeah, I just tried the Just Trains website, and their website doesn't come up anymore as a website.
Oh.
Yeah, that's a real sad problem.
Yeah, it used to be a nice
Just
store.
Trains used to be, for me, 10 miles away and absolutely great. But I'm afraid things have just gone to shit.
Yeah.
Mm-hmm.
No, I don't know that's anyone their fault necessarily. I think it's just it's the ongoing change. It's hard to be in the hobby shop business.
Yeah.
The challenge with it is you can,
I know it's a problem, and with so many of us like myself, we want very specific things, and actually, it's so much faster to email order them than to wait for the weekly shipment from Walther's at the hobby store.
Mm-hmm.
Yep.
Well, it looks like the model that they use in the Midwest, where they have a physical shop, but they also have a big thriving internet business, seems to work. I don't know why doesn't anybody try doing that over here.
Probably labor costs combined with housing costs.
Yeah, probably the cost.
Yeah, no. It's because of the price of those huge warehouses to support it. You can't you can't do it in the Bay Area.
Mm-hmm. Yeah.
It's real. Means we now have to go to the train shop all the way down in Santa Clara.
Yeah. Seems like all the warehouses in the Bay Area are centered around Tracy. There's a whole ton of warehouses down out that way.
Yeah, I think
there used to be a great shop in Lodi.
Oh yeah,
they closed.
Yeah, Rogers. Yeah, I found that place about 2 months before he closed down.
But by the way, I didn't bring up one thing I should bring up. We're going to have an NMRA booth at the Great Train Show, and there is a sign up online. It's been in the last couple of I did send a thing out on it on an email. I'm going to send another email out probably early next week. is anybody interested in doing the train show? Bob, you've got to do the train show.
I'm negotiating for time with my wife. I think I'll be there.
There you go. This is
I greatly enjoyed doing that.
This is the one in
It's
Pleasant.
way better than pitching at a trade show.
This is the one in Pleasanton. So, the cool thing about it is you get free admission. It's not a huge event. They're going to be like 9 modular layouts, and then the club will be open there. The vendors are typical vendors. Sometimes there's some interesting stuff there. But yeah, if you're interested, look in your emails. I'll send another email out. There's a sign up online. I can actually put it in the chat too. I'll put it in the chat also.
Speaking of which, I went up to Sacramento for their International Rail Fair, and it was pretty good.
Yep, no, that's a good event. They do that well up there. The thing that's interesting is that we've never had an event here that was a PCR Coast Division event, and I kind of wondered whether we wanted to do that. Try to have some sort of a train show that we ran. We've always just had the GTS show, but it's a lot of work to do it if there's interest. If you look at Sacramento at the International Rail Fest, the group that runs that, I think there are about 8 or 9 people that are involved in running it. So you got to have some people really focused on doing it. It's kind of like running a half a convention every year.
Hey, Ken, I got to get going, but I put my email in a private chat to you. Reach out to me.
Yeah, I got it.
Okay, cool. I got to go, guys. Hey, thanks a lot. Great meeting, Phil.
Thanks, guys. By the way, I'm going to put in here. I'll put the Pleasanton sign up here in the chat. So if you're interested in signing up, it's in the chat.
Okay.
Yeah. It basically you get in for free. You have to pay for parking. If that's a hardship issue, the coast will pay for it. So not a big deal. The fare charges for parking. So. Well, good. Well, if there's nothing else anyone wants to bring up, I guess we'll just call it a day. And we can have a great rest of the weekend, and we will see you. I think we have one more meetup here before Christmas. So we'll be getting back together, and let's see, we've got the 13th, and then we'll probably do the 27th, which is during Christmas, but not on Christmas Day or Christmas Eve. So
will you be doing that from the train show? Because isn't the 13th the train show?
What I typically do is I go in the afternoon. Though this time I may not. I probably will do it from the train show. I'll probably talk to Jesse and see if he can cover it in the morning. Okay. If he's not at the train show. But I'll try to join it from the train show. You're probably right. I didn't think about that. Always a challenge.
Yeah.
As these Saturdays get more, I've
unfortunately I'm useless being deaf.
Yep. No, I understand, Ken. It's but you come and build a model and show some modeling. That would be fine. We'll set the tables up this time so we can have a little modeling demonstration next to our table. It's one of the things I'm finding is Saturdays are becoming somewhat challenging from my perspective. I've been invited to a few operating sessions and stuff on Saturdays. That's been my conflict, and why you saw Jesse a couple of times. But that's life.
Okay, well, Jesse had his first meeting for those of us going after the Golden Spike Award.
Yep.
Yeah, that was a good meeting.
Cool. No, I think it's great. It's I think the AP program is it's a really good way to get yourself focused. I actually did a bunch of them now, so want to now I've got to focus on cars, which I probably would never have done cars type stuff if I didn't have to focus on it for the AP.
Mhm. Well, the only thing I'm upset about the AP is the volunteers section, where they only count volunteering for the NMRA for any credit. If you volunteer for other parts of the hobby, you get no credit for it.
Yeah, that's true.
I mean, being a project manager, the Project Management Institute not only recognize work you did for the institute, but they also recognize any work you did for the, the occupation. And I don't know why NMRA doesn't do that.
Yeah, I think that's kind of the one thing that's kind of NMRA focused. I know, like the author, if you do a clinic for a non-NMRA event, you can count that towards your author. If you write an article for a non-NMRA magazine, you can. But the volunteer is kind of trying to get people to volunteer to help the NMRA, because I think part of it is that they know that there's a lot of club-oriented stuff that would potentially fit in if it wasn't just NMRA limited. I don't know. I was never involved in the discussions on it, so.
Well, when I first joined the NMRA, I'm thinking, okay, this, the program, the AP program, I could do volunteer work, and I was all set and ready to do that. I do a lot of, work at the Golden State Model Railroad Club and things like that, and I help kids out learning about the model railroading. But then when I looked at it and it says, no, only NMRA functions count, I'm sitting there going, really?
Well, Larry, I have a proposal for you. If you'd like to take over these Saturday morning things for a while, they all would count as volunteer time.
Mm-hmm. Oh, they do?
If you run this meeting, that's volunteering. I mean, I'm not being in any way facetious or anything. I'm saying,
no.
If somebody doesn't show up to run this, it ain't going to happen. Therefore, you're volunteering. It's a Coast Division event, just like everything else.
Oh, okay.
Yeah,
I did one time.
Or if you come to the train show, volunteer at the train show, that's volunteering at an NMRA event.
Yeah.
I mean,
I did that last year. I'm trying to negotiate with my wife to see if I can go this year.
Come to the auction, raise your hand, and volunteer at the auction. 4 hours. Moving stuff around at the auction. Just come at the back and move stuff around at the auction. That's 3 hours of volunteering.
Okay.
Just keep track of it really, what you don't realize is a lot of the things we spend our time doing anyway, if you just tweak it a little bit, becomes volunteer time, right? You go to an event, and sit there, you say, hey, I'll be the room monitor, at a convention. You say, raise your hand and say, I'll be a room monitor for these clinics in the morning. You're sitting there for 3 hours listening to the clinics, telling people when to talk, and you get 3 hours of volunteer time. So,
okay.
Yeah, it maybe one of the things.
Speaking of which, can I get credit for being one of the monitors at the 21 NMRA convention that was online?
Sure, absolutely. Just document it that, hey, I did this at this time. That's anything like that is volunteer time. Anytime you do something to help and facilitate. I mean, I definitely get Earl to talk about it. One of the things we've been trying to do, and I don't know if we try to do this on the coast, we were going to try to do it on New Tracks, was try to have some programs. And one of the things I was going to do is have Chip come in, because I don't know if you know, Chip has done a clinic on getting your author certificate. And, that was, it's, once you start looking at it, if you've done a few things, written a few things, done a few clinics, all of a sudden you find you've got almost all the points you need to get an author certificate. The one that's harder to get, to my mind, is the official, because you have to be in certain roles to get points to be an official. But the volunteer, like I said, if you're interested, if someone's interested, I have plenty of things you can do to volunteer that don't, are like I said, align a lot to what you're already doing. Like I said, coming to an event like either the auction or we go to a train show. We're going to do both a train show in Pleasanton and a train show in this year that we're going to do with Red, the one in Vallejo. They moved the San Jose great train show to Vallejo. And so we'll have both of those, and come and do a shift or two at those, get to go to the show, look around, and you do those for 2 years. That's 30, 40 hours of volunteer time. Doing things you actually kind of enjoy. And like I said, if someone would like to kind of take this over, I'd be more than glad. I definitely need someone to take on doing some writing, the website, etc. So all those things are pretty easy things to do, and all of them count as volunteer time. So anyway, well, I'm gonna bid everybody adieu. I'm home alone with the dogs, and we have a new shepherd, and he's getting antsy that I'm not around with him. I'm back in the office. So
all right.
Everybody have a great couple of weeks. Hope everybody had a great Thanksgiving.
Yeah.
And
Bye.
Yep. Happy holidays, guys.
happy. Have a good one. Bye now.
Take care. Bye-bye.